with the universe expanding violently outward from an infinitely small speck, would never gain wide acceptance. Hubble's incorrect estimate for the age of the universe allowed a competing theory to emerge from the halls of Trinity College, Cambridge.
There was a tenable alternative to the Big Bang theory, namely the steady state theory, which allowed the universe to exist from everlasting to everlasting.
The steady state theory championed the static universe that the primeval atom concept rejected. Proposed by astronomer Fred Hoyle, it was built upon a theory of the origin of elements, nitrogen, carbon, and more than 100 others in the periodic table. Under extreme temperatures, hydrogen fuses to form helium, and helium fuses into entirely different, heavier elements. Fred Hoyle believed this nucleosynthesis, the creation of new elements, took place in the cores of very hot stars. That was an absolutely staggering achievement at the time. Hoyle's achievement was to teach us that everything after helium in the periodic table is actually stardust. It is in the stars that these things were made. But the theory couldn't account for the formation of hydrogen and most of the helium in the universe, because the first stars must have been made of hydrogen already in existence. This existing hydrogen makes up more than 74% of the detectable universe. Hoyle sidestepped this problem by adopting a widely held belief that hydrogen and helium had always existed. In fact, according to Hoyle, the entire universe had always existed. No beginning and no end, just a steady state. In a nutshell, a steady state universe is a universe that's always been here, always looks like it does now, always has the same average density, has the same temperature.
There was just a little problem, though, which was people knew the universe was already expanding. When the distribution of matter expands, it becomes more dilute. Now, if the universe is very old, it would be infinitely dilute.
Hoyle fixed this flaw by assuming that somewhere matter was always being created in the universe. But the wholesale creation of matter was a hard pill for physicists to swallow. And Hoyle had a nemesis of sorts in the Russian physicist George Gamow, an admirer of Lemaitre's primeval atom.
Gamow was usually present in these discussions, and he always brought up nasty questions for Hoyle to consider. Questions that the steady state had difficulty dealing with.
Gamow turned to atoms, as Hoyle did, to support his competing theory. Gamow suggested that hydrogen and helium and the other elements were created in the first fiery minutes of the universe, in a Big Bang, when temperatures were thousands of degrees hotter than they are in the core of any star. But Gamow was a better idea man than he was a mathematician.
And he had to turn to this phenomenally talented graduate student of his, Ralph Alpert. And it was really Alpert who was able to push this idea through and come to a conclusion that if indeed the universe synthesized the early elements, there should be roughly 10 times as much hydrogen as helium. And that matched the observation. Fantastic moment.
Alpert, with colleague Robert Herman, refined Lemaitre's prediction of detectable remnant heat from creation, a strong clue supporting the Big Bang.
George Gamow and his students asked a very simple question. If the Big Bang was so hot then the aftershock, the afterglow, the echo of the Big Bang can't be so cool now. So the residue should be measurable today.
Unfortunately, no one had the right telescopes in 1949 to measure the radiation or heat.
left over from the moment of creation. And at the time, there were other problems with the Big Bang theory. It offered no explanation as to the origin of the elements beyond hydrogen and helium. At the same time, steady state garnered widespread media coverage.
The steady state theory was popular with the general public because Fred Hoyle was a master of popularization and just going out and marketing his wacky idea.
Ironically, the term Big Bang was coined by Hoyle in 1949 during one of his popular radio broadcasts. He later used it as a term of derision.
I think there was a dislike in their relationship. They didn't see eye to eye on most of the things they were thinking about. So I think Hoyle came off the worst in battles. I think he did more fighting for his views than was merited, but that's a personal opinion.
Fred was a very, very brilliant and innovative sort of person. Ideas just poured out of him. Some of them were good and some of them were bad, and he didn't always know which was which.
By the 1960s, Hubble's inaccurate estimate for the age of the universe had been corrected to reflect more accurate data, resolving one challenge to the Big Bang theory. Still, it seemed the battle between the steady state and the Big Bang would end in a draw. But then, all of a sudden, scientists found a smoking gun, one nearly as old as the universe itself. Its discovery doomed one of these theories to the dustbin of history.
The universe